Good afternoon. Our team, Make Earth Cool Again, have a climate action-based solution for challenge number 3, groundwater in remote atoll communities and issues dealing with declining quantity, salinity, and rising levels. In the Pacific Islands, coral atolls rely on rainfall for their water. Due to climate change, this will be severely impacted by reduction of rainfall and reduced land area size from rising sea levels. In periods where there is a reduced rainfall, atoll communities rely on pumping water from their groundwater supply, which reduces their total freshwater quantity. Reduced availability of fresh water causes several implications. With increased use of the groundwater supply, salinity of the source can affect its non-potable uses, expose building foundations to harsh conditions, and damage crops. Rising sea levels increase the risk of human waste contamination, which reduces the reliability of the groundwater supply. Our mission is to improve the rainwater collection systems to reduce the reliance and frequent use of the island's groundwater supply.
We chose to focus on Whangawhale due to the larger population's reliance on rainwater. Our research shows that all rainwater captured is runoff from roofs to water tanks on residential property, while other surfaces are not utilised. We believe there is a more efficient way to capture rainwater from these areas, such as runoff from roads and specifically the airstrip. Whangawhale receives an average of 200 millimetres of rainfall a month. Therefore, each month, roughly 12,320,000 litres of fresh rainwater that lands on the airstrip goes to waste. We propose a novel application of water-sensitive urban design in this context, providing a sustainable source of clean water for the community.
We have taken a strengths-based approach to integrate into a system that is already working and accommodated by the community. We propose an innovative hybrid of bioretention and filtration swales, which will harvest water running off the paved airstrip and filter it. 3 swales will lie along the perimeter of the airstrip, broken up into 200-metre step increments. Each step will start at ground level and drop 1 metre across its span. This is equivalent to a slope gradient of 0.5%. This gradient allows water to slowly flow downhill through the swales without the need for an expensive electricity-dependent pump. This unique and original solution has the potential to generate high volumes of fresh water. The swale consists of different layers of gravel, sand, and soil, all of which are locally available. These materials will filter the water as it permeates through them. Buried at the bottom of the swales is a perforated pipe, which will collect the filtered water and channel it into water tank storage, conveniently located next to the existing desalination plant. This provides easy access to the chemical treatments currently used on fresh desalinated water to ensure it is at a drinking standard. These post-desalination treatment facilities will treat the water freshly filtered from the swales in the same way, but without the negative environmental impact associated with desalination.
We will source the pipes from a local construction company, using polyethylene if possible due to its corrosion and chemical resistant properties. It is also extremely durable, with a lifespan of around 100 years, thus cutting down on maintenance costs. Further storage capacity exists in the swales themselves. During heavy rainfall events, the large gravel component of the swales will become waterlogged, acting as a buffer for the water tanks and further increasing the retention capacity of the system. The third swale is not connected to the desalination plant and instead flows directly into a water tank without further treatment. This water can be used by the nearby firefighting station or as grey water for the community to use in plumbing facilities. The team has in fact considered all challenges relating to this design, and the construction of the swales is incredibly cost-efficient, simple, and uses the available machinery on the island. Maintenance is not technically complex and is achievable by the local community. The incremented design means a slope can be achieved without needing to dig into the groundwater.
In 2012, an assessment conducted by USP highlighted the potential for local government to use the airstrip as a water catchment, emphasizing the feasibility of our design. Utilizing the local community's skills and capability, its implementation will be cost-effective, practical, and deliverable by humanitarian organizations. Beyond Whangawhale, other Pacific islands with sealed roads can implement a similar solution for rainwater catchment. In lieu of the islands having desalination plants, our swale solution can be integrated into other water storage systems and plumbing. Our design provides the Whangawhale community fresh water by tapping into the millions of litres of wasted rainwater falling on the airstrip. This ensures their scarce groundwater can be set aside for emergencies and droughts.